Hello everyone, my name is Finding Pepper and welcome to episode 5 of the Paper Minecraft tutorial series, previously known as the Terrain Generation series. We're basically done with the terrain generation part, so now it's just Paper Minecraft. This episode we will be adding a player. Now I know a lot of you have already added players to your games, which is great, so this might not be the most interesting tutorial for everyone. However, I feel like I need to include it to have a full tutorial. Can't miss any bits. So let's get started. Alright, first I will go to my assets project. There's a link to it in the description. And then I'll grab the PMC5 sprite, stands for Paper Minecraft, and I'll drag it into my backpack. Then head back over to my project. Alright, drag it out. Let's look at what we have. We have some heads and various parts of Steve's body, and that's because I'm going to be animating the player with a different method than is normally used. You know, I could use the normal frame-by-frame animation, but I thought I would do something different, and also this can give you a bit more control on the specifics of how you want your player to be animated. Alright, now I'll create a new sprite called player, and I'll drag all the costumes into the player sprite. And now I can delete this sprite. Great. We'll want a new message for our player. So in game loop, I'll broadcast new message, move player. I'll also broadcast a message, stamp player, after we stamp tiles. Then I'll get a when I receive, move player. We need to make some variables for our player. So I'll make variables x, and these are all for the sprite only, y, speed x, speed y. Now these will of course hold our position and speed in given direction. Now let's make some blocks for movement. I'll just start with a move x custom block, run without screen refresh. I'll put it under move player. Let's do some basic side to side movement. Set speed x to, and then we do our trick of key right arrow minus key left arrow pressed, and then we multiply it by 6 to give it a more substantial amount. And Minecraft uses WASD, so I might change this to D for the right arrow and A for the left arrow. Then we'll just change x by speed x. Now when I receive stamp player, we will go to an x of x minus camera x, and y of y minus camera y. So this is our basic scrolling positioning. If you've done any other scrolling games, I'm sure you will recognize this. Then we can stamp. We can hide the player because the stamp block works even if we're hidden. We should also have some scripts triggered on setup, so when I receive start game, then I'll make a block called reset, run without screen refresh. We'll just set x to 0 and then set y to, I'll say, the middle of the world vertically, so world height divided by 2 times tile size. Now let's run this. Now when we press our W and A keys, we should see the tiny little blue leg image move left and right. Now I'm just going to increase the size to 200 so it gets to be correctly sized. So right now our left and right and up and down arrows still control our camera. Let's have our camera follow our player. So I'm going to separate off the things that control the actual camera in the when I receive move camera, and we're in the backdrop. I'm going to drag this into the player sprite, and then delete it from here, and just leave the sky coloring. Now back in player, I'm going to make a block called move camera, run without screen refresh, and when I receive move camera, we will use this block. Now I'll change the change camera X to a set camera X, and then I'll set it to the player's X and Y. Now I'll add a bit of damping to the camera. Rather than setting it, I will change by the difference between X and camera X, so X minus camera X. So this alone will do exactly the same thing, but then we can divide it by, say, 4 or something, and now it will move a bit more slowly. And then I'll do the same for camera Y, change camera Y by the difference between the Y and camera Y, and then divide it by 4. So now the camera should lag behind our player a little bit. Okay, let's add some Y movement. I'll make a block called move Y. Run without screen refresh. Okay, so we'll start by having some downward acceleration for gravity. So we will change speed at Y by -3. I'll put a limit on this, because if we fall too fast, we might be able to fall through tiles in some cases. So I'll say if speed Y is greater than -28, so then we will change speed Y by -3. Now we can change our Y position by our speed Y. Let's also add some jumping, if you will. When key space pressed, we set speed Y to 16. Let's run this, and we should be falling, and then when we press space, we'll jump. Now if we hold space, we just go upwards. And yeah, we can just jump midair. Our next order of business is to add collisions. So these collision scripts I'll be using are essentially Griffpatch's collision scripts from the tile scrolling platformer. So I'll make a block called handle collisions at X, and then input X, text input Y, and then input Y, then a text label direction, then an input Xdir, and an input Ydir. Run without screen refresh. Now our Xdir and Ydir are the directions in which the player is moving. Now we also need a way to get the tile at our current position. Make another custom block called getTileAt X, and then an input X, Y, and then an input Y. Run without screen refresh. Okay, so we need to make a variable, grid index for the sprite only, as well as tile and tile shape. So our grid index will hold the position in the grid list of our current tile. To find this, we need both our Y position in terms of tiles and our X position in terms of tiles. We can get this by dividing X by tile size and then taking the floor. And then we can do the same for our Y. So these two values are the positions of the tile that we're on in the grid. Now the X, we need to multiply by grid height, or world height. Because whenever you move one tile right in the grid, you actually are changing your tile index by world height. Because if you think about it, you have to loop all the way up in the grid and then come back around until you get to the tile to the right of you. Okay, so we add these two things together. Now this will get it so that the bottom left tile in the grid is 0. But actually lists start at 1 in Scratch, so we need to add 1 to this. Okay, and now this is our grid index. Now our tile will be item grid index of grid, and our tile shape, we need to find it in the tile data list. So if we remember the formula from tiles, I'm going to find the find property block and drag this block into the player sprite. And I'll find property number. I believe tile shape is 2. Let's just show the tile data list, and yep, shape is number 2. So find property number 2 of tile at grid index. Alright, so once we've done this, we can set our tile shape variable to temp, which is the value returned from find property. Alright, so back in handle collisions, let's get tile at our current position. So get tile at xy. We want to know if we are on a solid tile. Now if we're not on a solid tile, we don't need to do collisions. So I'll check if tile shape equals the empty value, and then I'll just stop the script. Okay, now if the script continues, then we have a tile shape of greater than the empty value. And now we need to push our player out of the tile. Now the direction that we get pushed in depends on the direction we're moving in. If we're moving to the right, then we need to get pushed back out to the left. And if we're moving up, then we need to get pushed out downwards, etc. So I'll have a series of if statements. I'll start with if x_dir is less than 0. Then we change our x position. And now we're going to get the difference between the top of the tile and where we are inside of the tile. So the top of the tile is at tile size. This is assuming the bottom left of the tile is 0, 0. So the top of the tile is at tile size, and our position is at x mod tile size. So if we're halfway into the tile, then our x position would be 16 in relation to the size of the tile. So we're changing our x by this difference, so we should be pushed up to the top of the tile. Now if our x_dir is greater than 0, meaning we are moving upwards, we need to get pushed downwards. Now we still want a difference between where we are, but now we want to find the bottom of the tile, which would be 0. Except 0 is actually slightly colliding with the tile. Anything less than 0 would not be, but 0 would still be counted as colliding with the tile. So we actually need to take something a little bit less than 0, so like negative 0.01. Now we'll do the same for our y_dir, replacing all the x's with y's. Anything that says x will be replaced with a y. Good. Now finally, I'm going to make a new variable called solid for this sprite only. And if we collide with something, we'll set solid to 1, and at the top I'll set solid to 0 for now. Okay, now we're going to use this block. I'm going to first use it in move x. So I'll handle collisions at xy in direction, and then our x_dir will be speed x, and our y_dir I'll put a 0. Now because I'm putting a 0 here, this will make sure it won't push us out vertically at all. You'll notice in this block we only have checks for if x_dir and y_dir are less or greater than 0, not equal to 0. So if they are 0, then we won't handle collisions in that direction. So this means we can first move in the x direction, then handle collisions only in the x direction, and then do the same for move y, and then handle collisions only in the y. So we won't get pushed out to the wrong side of the block. Okay, before I do the y, I'm going to say if solid equals 1, so we collided with something, then we set speed x to 0. Okay, now we'll do the same for the y, and then put a 0 in the first input and a speed y in the second input, then change this to a speed y. Okay, I'm also going to make sure I put our if key space pressed before our change y, so we make sure we actually move by speed y before we check our collisions, because otherwise we'll have a positive speed y but still be inside a block slightly. So I'm going to run this and see how that works. and we are colliding. Let's try jumping, and that is working just fine. Water we can still stand on, but first I would like to make it so we can not just jump infinitely, so that we can only jump once while standing on the ground. Okay, so I'll make a new variable called falling for this sprite only, and that will store how long we've been in the air. So I'm going to turn this if solid equals 1 and else. Now in the if part, so if we have collided with something, we'll set falling to 0, so we are not falling. In the else, we will change falling by 1. Now inside if space key pressed, we'll check if falling is less than 1. So that means we are standing on the ground. Okay, let's try this. Okay, so now we can only jump while we're on the ground. Let's see what happens if we jump into the bottom of a block. We can sort of stick there. I don't know if you saw that. That's because this is setting falling to 0 even when we collide both horizontally and vertically. So what we need to do is check if speed y is greater than 0, so we're moving upwards, then we'll set falling to say 99. That will definitely cancel our jump. And in the else, we'll set falling to 0. So if we're moving downwards, we'll set falling to 0. If we're moving upwards and collide with something, then we shouldn't be able to jump after that. So we'll set falling to a big number. Okay. And there we go, that works. Okay. Now this is rather difficult to test. It took me a while to find a spot that I could do that in. So I don't expect you to test this. You can just trust that it works. Okay, let's get some better player animation. I'll go into when I receive stamp player and I'll make a block called display player. Run without screen refresh. And I'll move what I have here into the display player block and put it onto the when I receive. Okay, so we have several parts we need to animate, and we can do this by stamping each of them individually. And you'll see that these are a bit 3D, so we need to make sure to stamp them in the correct order. For example, it would look weird for the arm that should be behind this torso to be in front of it. We're going to start by stamping the legs. I'll change Y by -10 and remove the stamp block for now. I'll change X by 2, switch costume to leg just normal, not leg 2, and then stamp, then change X by -4, and then stamp again. So those should draw my 2 legs. I'll run that, and now we have 2 pairs of legs, and they are seeming to not collide correctly, but that's just because we're drawing them below the center of the player, and we'll fix that later. Now let's draw one of our arms. So I'll change Y by 22, change X by 8, switch costume to arm, then stamp. Now we can draw the torso, so I'll change X by -6, switch costume to torso, and stamp. I'll also need to change Y by -8 because the arms are positioned so that the center is at the top of them, so they can rotate better. Okay, then we change X by -6 again, and then we move back up by 8, switch costume back to our arm, and stamp again. So let's run this, and now we should see arms and legs. Now you can maybe see better why we had to draw our arm, and then our torso, and then our second arm, so they are layered correctly. Okay, finally we can draw our head. We'll change Y by 12, and we'll change X by 6. Switch costume to head, and stamp. Run this, and we should have a full player. Awesome. Okay, but our player is certainly not colliding correctly. That's because our collision scripts collide based on the center of our player, not the bottom or the top or the sides. Okay? They don't know how big we are. So I'll make some variables, width for the sprite only, and height for the sprite only. In reset, I'll set width to 8 and height to 30. While I'm here, I'll also set our speed X and speed Y to 0. And set X to something slightly more than 0 so we don't spawn all the way at the edge of the world. I'll make it like 128. I'll set speed Y to -1 actually, so we have some downward speed when we start, so it will know to push us back up. Okay, now we'll actually make a new block called handle all collisions in direction, and then xdir and wider. Okay, run without screen refresh. First of all, I'll move our solid from our handle collisions up to this block. And what this block will do is handle collisions not just at the center of our player, but also at several points on the edges of our player. So we'll repeatedly use our handle collisions at block. We'll handle collisions at x minus width and y minus height. So that's the bottom left corner. And for the direction, we'll put our xdir and wider. Then x minus width and y, so that's the center left, and then x minus width and y plus height. So that's the top left. Now we do the same thing for the right. So x plus width, and then the y's will be the same. Cool. Now we need to replace our handle collisions blocks here with our handle all collisions in direction, and put in speed x and 0. Same down here, but we have 0 and speed y, just like we did for our handle collisions at. Run this, and now our feet are firmly touching the ground, and we can collide left and right with the blocks here. That is great. Okay, let's get some slightly better animation for our player. The first thing to do is to allow the player to change directions. So I'll make a variable called dir for this sprite only, stands for direction, and move x with an if else. We are moving to the right, so if speed x is greater than 0, we'll set dir to 90. And in the else, if speed x is less than 0, we'll set dir to negative 90. If our speed x is equal to 0, we don't need to set our dir. And I'll put this before our handle all collisions block. Okay, so in display player, we need to point in direction dir. Let's run this and see what sort of fun things we see. Aha! Yes, lovely. It looks kind of funny, but it's definitely not what we want. So this is where our upside down costumes come in. Because if we have an upside down costume and then we turn it upside down, then it becomes right way up. Okay, so let's use our temp variable and set temp to dir divided by absolute value of dir. So that means if dir is positive, we'll get 1, and if dir is negative, we'll get negative 1. That's just how division works. Now, every time we switch costume, if temp is less than 0, so that means we are moving to the left, we will next costume. So I'll just put these here. Okay, run this. And now we look slightly more correct, except we have some layering issues. Those shouldn't be too hard to fix. We just need to move left and right in the opposite direction. So every time we change x, we have what we changed by and then multiply it by temp. So if we're facing to the left, we change x by negative all the things. The y we can leave the same. So I'll just go ahead and do that, replacing every change x with the number there, multiplied by temp. And make sure you got this for every single change x. It's important. If you see something off, that's probably why. And look, here we are. We look just fine in both directions. Now, shall we add some walking animation and jumping animation maybe? Okay, so what we want to do is rotate our different parts by certain amounts depending on what we're doing. So I'll start with the leg. We only want to turn it if we're not standing still, so if we're moving. If not, round speed x equals 0, and we're rounding it so that if we're very close to 0, it will still animate as if we're staying still. So if not round speed x equals 0, then we turn. And then how much do we turn by? Well, we need a variable to keep track of our animation frame. So I'll go ahead and make that. Make a variable called frame for the sprite only. So in move x, if speed x is greater than 0, or speed x is less than 0, then we'll change frame by 1. And if neither of these are true and we are standing still, we'll set frame to 0. Okay, now we can do this. We'll turn left by sine of frame, and we're using sine because sine oscillates between -1 and 1. Now that's a very small amount to turn, so we'll multiply that by 30. So it will oscillate between -30 and 30. Now it will oscillate very slowly if we don't multiply by frame. So I'm going to multiply frame by 45. So now when we walk, we do this weird jiggly thing. Okay, yeah, that's not good. Okay, I'm turning left for this leg. Now I'm going to turn right for the other leg. And make sure to point in direction dir before we do that, and point in direction dir afterwards. So those are the only two things that will turn. Now we have our little legs moving. Let's animate our arms also. I'll just copy these blocks up here. So I'll take this first one and put it right after we switch costume to arm. And then I'll take the second one. We need to put it the second time we stamp our arm, which is after the torso. So right down here. And then we of course need to put a second point in direction dir afterwards, so our head does not waggle back and forth. Okay, run this, and now our arms and legs are moving. Let's see what the jumping animation looks like, and it looks exactly the same, so maybe we should change that a little bit. So starting with the legs, get an if else, but we put the turn block we have here in the else condition. And the if will check if round speed y is greater than 0. So if we're moving upwards, then rather than turning this, we'll just turn left 45 degrees. And then same for the other leg, turning right this time. And I'll do something similar for the arms, keeping what's inside here. I'll rotate by 30 here though instead of 45. And then, yes, turn left for the first one, making sure we're turning in the same direction as the one we had before. Let's try this out. This seems to be working pretty well. Now let's see about swimming. In our handle collisions, if tile shape equals tilde, meaning it's water, if our solid is not 1, then we'll set solid to 2. Instead, 2 will mean water. And the reason I'm making sure solid is not 1 because we don't want this to overwrite other collisions we might have. Okay, so we need to change the move y script a bit to handle water. So we'll get an if else and put our if speed y is greater than -8, change speed y in the else condition. And I'll make the check if solid equals 2. And I'll duplicate what we have down here, but change it to greater than -8 and change by -1. So we fall significantly slower in the water. Now I'll do something similar in our if space pressed. Get another if solid equals 2. Put what we have in the else. In the if, we'll just set speed y to 8, and we don't need to worry about falling being less than 1. Find some water. Let's see, and we can now fall down slowly and then rise up. Let's make sure our other collisions work fine. They do. Good, and we can swim up and down. Alright, so we have successfully added a player. Great. And that marks the end of this episode. I hope you enjoyed. I hope you have a great rest of your day, and goodbye.